Started, I would request to start the recording. Okay, so welcome everyone to today's webinar organized by the IEEE Photonics Society Bangladesh section. So we have with us our speaker Ryan Gardner today. So I would kindly request our treasurer for the IEEE Bangladesh Photonics Society chapter to introduce today's speaker, and then we can start the session. And we'll have a question answer session at the end. Okay. So yeah, I mean, Dr. Habib, you can probably introduce the speaker now.
Thank you, Dr. Manul Hussain. Hi, everyone. Good evening. Thank you for joining today's webinar arranged by IEEE Photonics Society Bangladesh chapter. I'm happy to introduce today's speaker, Ryan Gardner. Ryan is currently working at RKD in Engineering Corporation. It's located at Santa Cruz, California, USA. Before joining RKD, Ryan worked at Quanergy, if I'm pronouncing correctly, where he heavily worked with optical system devices. He's gonna share his experience today with us. The title of his talk gonna be the photonics industry under the lens of a young professional. With any further delay, I'm gonna request Ryan to start his talk. Ryan, floor is yours. Please share your slide and you can start your talk. Yeah.
Oh, yeah. God. Let's see. Share screen. Okay. All right. Can everyone see my screen?
I can see.
Can it? Okay. All right. So, thank you guys for inviting me here. I'll try to go a little bit faster since I had some issues with the connection. So I'm going to talk to you about the photonics industry. It's a field that I really have fallen in love with, and there's a lot of reasons for electrical engineers to be interested in it. So first, I had graduated from Texas Tech University with a BS in physics and a BS in mathematics. I wanted to learn more applications. I really enjoyed electromagnetism, and especially the sections on radiation and waveguides. So I decided to go and get an MS in electrical engineering. This is where I met Hassan all those years ago. It feels like it was really just about like a couple years ago, but it's been 7 years since I started that. After graduation, I spent time with personal projects as well as trying to work with a few other people. A lot of this was unfunded, which has a lot of difficulties. That is, you are often unpaid. Due to some really personal reasons, I experienced a fire in my hometown. And it was at that time that I really did need to work. My hometown burned down in November of 2018. And I began my first career job in January of 2019. So just 2 months later. There is a lot of work out there. So 2 months I was looking for the job and I got it. You never really want to end your education. I buy books really every month. I buy books on subjects, on anything that's remotely related to what I'm doing at the time or what I'm interested in. You want to have a library going. You want to have books you can reference. I have books that are on the same subject. I have several books on introduction to optics because I am always going back and looking at it. My first job, which I still work today, was RKD Engineering Corp. They make equipment for the semiconductor industry. basically, the company's focus is to open up computer chips without damaging them. You'll see this picture to the right. There's the computer chip, then you have all these bond wires that go to the chip. Companies want to open these up and have them still turn on. That chip, if it was done right, could have leads soldered to it and connected to it, and you could check if the circuit is working properly. You can perform all kinds of analysis. You can do electrical testing, you can do thermal work. So I learned how the jet etcher is built. This produces little micro aliquots of fuming nitric and fuming sulfuric, brings it right to the semiconductor package and opens it. Now, involved in this is optics. There are sensors that you use to determine if you have leaks, your gas, any gas flow, or any fluid flow. So this is kind of a beginning for me to explore a lot of work. Because this company was small, I had to learn everything. I did everything from sweeping the floors, maintaining the labs, to machining. I gained experience machining plastic. I machined aluminum, steel. I learned how this tells you how to put a design into a real product. You can think of having, a series of 10 or 20 lenses together for whatever you want to do, but this has to be physically made and sat somewhere. So having that perspective is really important. I'm greatly appreciative of the fact that I've spent 3.5 years here. And in the future, I still plan on doing work with them, even as I have other contracts and other work. So in my time there, became interested in diode lasers, machining, assembly. I became really interested in thermal work. The heat conduction from a laser diode changes how it operates. Changes how the beam spreads, changes wavelength, changes everything. This effect is seen in a lot of optics, where if you have a laser going through a lens, if the power is high enough, the lens heats up and the lens shape changes. So there is an endless amount of depth that you can, crawl into with any subject. So here you can see the Mega Etch. This is the flagship. This is the biggest product for RKD engineering. So you set a chip here. I don't know if you guys can see it, but there are 3 tiny holes. One is where the acid comes up to the chip. This nose keeps it forced down, and they have 2 waste tubes. So this will time and send precise amounts of fluid to the chip until it is open. This partially open up to whoever's operating it. You can burn through your device if you really want to. You can burn through your chips. But I was working on tools to help make this more accurate, to help give control. You can't see a chip directly while it's being etched. So you have to think of other ways you can see it. Other ways you can find evidence for, say, reaching the die, reaching any metal. It was a very interesting problem that I began to work on there. More recently this year, I worked as a display validation engineer at Meta. I worked there for about 5 months. This is my first contract job. There's some 70,000 people that work at Meta. So everyone has very singular jobs. each team is responsible for very narrow work, and each person is responsible for a much narrower portion of work. So what this can lead to over time are people that specialize in really, really niche areas. There are people that specialize in coatings of glasses or coatings of plastic. So that person may be very well suited for work in coatings and related subjects, but they may not know anything about mechanical assembly. They may not know how to design say a microscope system. But at the same time, it was a great thing to see how a large company comes together and gets anything done. I worked on their Oculus type products. I won't say exactly what. I work there in Sunnyvale, California, nearby Santa Cruz, where I live. Currently, I work a contract at Quanergy Systems. This company focuses on LiDAR for lots of applications. LiDAR is light, distance, and ranging, or LADAR, which is laser distance and ranging. Basically, you send out a pulse of laser light, it reaches a target, the light bounces back, and you find the distance to that object. This is the same principle as radar, except instead of being in the radio spectrum, this is in the infrared. So this is not a laboratory piece of equipment like I worked on at RKD. This is not a consumer product that I worked on at Meta. This is kind of in between, where a lot of companies will buy sets of these for security. They'll buy them for autonomous vehicles, maybe drones. But it's still a very much of a scientific hardware type piece of product. So this involves, how should I say this? Involves getting a team of people and running this and making sure that it is a safe product. This is not like my microscope that I worked on, where it would be enclosed. This is a product that people might put their face up to. So there's an added layer of working on the safety. So optics can be a dangerous field. It's not all just pencil work. There are lasers and electronics that can be harmful. I have been shocked. People have had lasers pointed in directions, not at any particular place. I'm not going to name names, but I've had lasers pointed in my direction that were not supposed to be pointed or on. But I really enjoy this work at Quanergy Systems. I could probably work there full time, and I'm going to talk to you guys about full-time work versus contract work, and having more than one job and different types of contracts. But first, I want to talk about this a little bit more. So Arcade Engineering being a small company, it allowed me to do a little bit of my own research. I was able to have the freedom to investigate ways that I could perform a job. I was able to bring things up of interest. It's a place where I've been able to do research that I like, while also still fitting in with failure analysis. This is kind of the thing about working versus academia. You don't get as much choice as far as your type of projects at work usually. You end up having to do whatever the company wants because that they're trying to make money. Academia, as I'm sure Hassan could probably tell you, you have a bit more freedom and what you can choose to start. You can choose to go into academia for a lot of subjects, so long as you can get a place. So photonics industry has been around for a long time. It really is a large field. It involves one of the fundamental forces. We see with light, everyone uses light to some degree. We use it on our homes, all our tablets, our laptops, our screens, our street lights made with LEDs. So for a long time, humans have manipulated light. People have learned that glass in a certain shape can burn things. Some had birefringence and allowed you to be able to see something bigger, like a birefringent rock. First compound microscopes, telescopes were at the end of the 16th century. One of the biggest companies in optics, Zeiss, was founded just about 150 years ago. And since then, there's been an explosion. The photonics industry is expected to grow past $1 trillion. Right now, it is about 700 billion. So this growth is rapid. And that means that there's a lot of room for people to enter the workforce, people to gain experience in this type of work. It's not a diminishing field. The need is just going to increase as we have more technology and it becomes a larger part of our lives. So if you look at the top 100 companies in the world, besides some finance companies, nearly every single company either uses a product or is heavily dependent. For instance, Amazon Web Services is dependent on optical fiber technology. A lot of our internet in the world now is traveling through optical fibers. Without optical fibers, a lot of our telecommunications would be just based on wires, and that was much slower. How should I say that? Yeah, so for some perspective, the video game industry is 300 billion, the movie industry is 136 billion. So if you think about the number of jobs that people are going for in these types of fields, there's a lot more work in photonics, and there's a lot of higher pay in photonics than a lot of other jobs in, say, video games or movies. But this leads to problems of where do I start? There's so many different types of jobs. There's 1,400 companies that go to Photonics West exhibition in a year. I went to the last one that I could in 2020 before the pandemic, and there's at least 1,400 companies there. So you could go from lens manufacturing, you can go to, AI detection of people's faces and security. You can work on camera systems. There's a lot of work with, say, phone cameras, or Canon or Nikon. Some of my first introductions to optics was actually wanting to do photography all the way back in grade school. So I learned how to take pictures. I learned about different lenses, zoom lenses, and now I have a much better idea of what work actually involved in performing some type of work like that. That is a difficult piece of equipment to make. If you start to really think about everything that goes on into the design of a Nikon camera. You could, for that camera, you could be an optical scientist specializing in the lenses. You could be specializing in the manufacturing of those lenses. You could specialize in optical alignment. The alignment of lenses and other detectors and emitters is also a specialty. You could be working on the actual camera itself, which will involve semiconductor physics. So for any of you that are really interested in semiconductors, you could look at working with companies that make CMOS or CCD or DMOS sensors. So types of employment. This is a kind of a difficult choice, and this is something that you're going to have to consider for your own goals and your own circumstances. But there's more or less three types of employment. There's full-time work, which is exactly what it sounds like. You have full-time job, usually 40 hours, sometimes 50. You may be still paid hourly, but often salary. You will be there for, they plan on you being there for years. There's not so much an end of a job when a project is done. There's always going to be work. If you're in full-time, you're on staff. You don't make as much money as if you negotiated as a contractor yourself, but you have a really stable employment. That is kind of the key benefit to full-time work. Third-party contracts. This is something I have experience with as well. My contract at Meta and my contract at Quanergy Systems are both through a third party. I didn't apply for either of these contracts. I got contacted on LinkedIn for both of them. So I got contacted, I got an interview, and I began work. I was really quick. I had no effort really on my part. They handled negotiations. However, keep in mind that when you have a third party, they have to get paid too. And this comes in two ways. They get a portion of your salary. So say that you're paid 80 bucks an hour. The company is actually that you work for is having to pay $100 an hour, and that third party agency actually takes, that 20 bucks. Agencies usually take anywhere between 10 and 20%. They also charge a large sum based on your salary, your wage, to release you from the contract. So if you want to be transferred from from contract to a full-time role, the company has to pay a large sum to do that. So it can be very difficult for a company to decide to take you from contract to full-time, because they're going to be taking a risk that they buy your contract and you only work there for like 6 months. So anything that you can do to show that if you really want to be a full-time employee when you start as a contract, you have to show that you have an interest in that work, and you have to be impressive, but it's also partially out of your control. In terms of contracts, a lot of companies get these contracts because they do not want to have long-term people in certain roles. They may only want people for a certain time frame or for specific tasks. So you can end up where you get the contract and you might actually get a renewal. Say if you have a 6-month contract, you might get renewed for another 6 months. But past that, if you're not going into full-time, you should probably find another job, look for another contract. You can also negotiate contracts through your own business. So I'm going to be starting my own business license soon, and I can describe how that will go. But it allows you to basically make yourself into an advertisement. You can hire yourself out to companies. It'll be project based. You do have to handle everything that comes with having an LLC or a sole proprietorship. I know people who have done this and they can make pretty good money, but you have to manage your time. You have to treat all your clients as clients. You go in and you do your work that they need, and then you leave. You don't spend time trying to really investigate long-term working in that field. You are trying to handle maybe 2 or 3 clients and being able to work with them through a project to get it done. So you might have 2 or 3 people, 2 or 3 clients that you're working with. You might have to travel. If you're doing a lot of contracts, they may not all be in the same place. You might have to do some remote work and as well as lab work. In terms of personal business, as far as doing a contract that way. I know someone who has their own business license and they've done work with Olympus microscopes, one of the largest microscope companies in the world. He's worked with defense contractors. He has worked with smaller businesses. So this is something that you can do, but it's extremely difficult. And usually people only start that after they have years of experience of full-time work. It can be hard to start a business like that if you have no experience in the field. So if you want to do that, I would suggest working for years in either a full-time role or third-party contract. So where is work? This is kind of narrow, but it's basically anywhere that there's a major tech center, there's probably some optics there. There's concentrations around Rochester, New York. There's concentrations around the University of Florida. California has a lot of optics schools that are good with optics. New Jersey, this is where Thor Labs is, as well as Edmunds Optics. These are 2 suppliers of essentially most of the optics that you want to buy, right? You can go and work for them there, and there's a lot of companies, hundreds, that are just nearby. So the other section of this is that most companies in the US and in Europe do not manufacture their own products at the end. They get sent over to be manufactured in Taiwan or China. So as I said, there's specialties in lens design, but also lens manufacturing. So if you do want to be more involved in manufacturing of optics and the studies of that, China and Taiwan is actually probably a really good place to look. But you guys all live in Bangladesh. I live in California. How do you have to move? Not necessarily. So COVID-19 more or less shut down all travel across the world. People couldn't go into work. I remember people taking home lab equipment into their homes, setting up their own personal quarter or half labs wherever they could just to continue work. I was fortunate at RKD Engineering that we were a small company and people were able to stay safe and well separated. Some labs, I heard of people at Microsoft, they spent time working in shifts. So where before everyone worked during the day, and then you had people that were day shift that started to work in the evening some days or at night. So where one shift became 3 for people who really had to be in the lab. So you can probably hear people's stories about that type of work. Yeah, but photonics still grew in this time frame, and it's still slotted to be a $1 trillion industry in just a couple years. So work from home became extremely commonplace in this time frame. Whereas before you had people who were designers and software people that they had to be in the building, but they never touched physical equipment. Now, this doesn't make sense. These folks can work at home if they really want to, right? So right now, there are jobs available that are purely remote, high paying, and they are in optics design. I've seen ads for work on optical fiber design, and remote. So if I start one of those jobs, I could be living in I could have it, permanent residence in the US, and I could go to Croatia, Russia, Japan, wherever it is, and I could work while I'm there. The downside is you might have to work at night to meet the mate to be able to go to the same meetings. Yeah, so that's kind of a downside to that. But there are jobs that I've seen ads for the 70, 80 bucks an hour, remote. You're not going into a lab ever. That is significant. I didn't see that before COVID-19 at all. So you don't necessarily have to move. Like, let's say that you live in California and you get a job in Florida. You don't have to necessarily move. If it's a remote job, you don't have to uproot your life, uproot your family. You can possibly work from home. This comes with it. You need to be able to actually work from home. You need to be able to have a good internet connection. You need to be able to have phone calls. You can't live out in the middle of nowhere. You have to be contactable. So that is one caveat. You can't go and live out in the middle of Montana very easily. So there are some skills that you should really pick up. You need to be able to know sines law. You need to be able to know the laws of refraction. You need to know what diffraction is. You need to know what wavelengths are. You need to know wave numbers. You need to have the general understanding of optics to get this work. I only had a few classes, and most of this I actually learned on my own post graduation. As I said earlier, I buy books all the time, and I continue to do so. I lost quite a few in that house fire a couple of years ago, but I've been gaining most of those back, and I've been buying new ones ever since. The other thing is that you want to dive deep into a subject. It's good to have a general knowledge, but you want to dive deep into a subject where you're interested in. You want to be able to have that depth. It's quite different from going from calculus to doing real analysis and then learning complex analysis. When you go that far, you understand more completely the general subject. So, for instance, I was working on microscopy, and I more or less settled on wanting to build a confocal laser scanning microscope. I didn't see any lasers that were suitable for my needs, so I looked into making a laser, a diode laser module myself. So I began to look at different types of diode lasers, and eventually I dived all the way down into working with how gallium nitride works as a semiconductor. Interesting thing is that Nobel Prize in physics, for those of you who are academically inclined, was for the blue laser diode, for a man named Nakamura. I read 2 of his books. believe. So he was a new PhD. He had no publications. He started at a company and they set him on a task. They gave him a fair bit of capital, but he ended up creating the blue laser diode, and this is used everywhere from flashlights to displays, everywhere. It was a big deal in the 90s, and he got the 2014 Nobel Prize for it. A couple years ago, Arthur Ashkin got the Nobel Prize for optical tweezers. Optical tweezers are a device where you can use lasers to trap small objects and manipulate them. Basically, as the name implies, you can use them as tweezers. People have picked up and moved around and manipulated individual cells, bacteria, and viruses. A huge part of necessary skills is optical software. Nearly every single job that you see listed on either LinkedIn, Indeed, Monster, anywhere that you're looking, will mention ZMAX. Some will mention Light Tools or Fred or Code V, but regardless, if you do not know an optical software, it can be very difficult to find a job in optics. I learned optical design first with MATLAB. MATLAB was something I was familiar with, and it's also more accessible. MATLAB for students can be, I think, about $100 USD. Full versions be 300 or 400, and they have a lot of packages that you could add on to. ZMAX can cost anywhere between 5 to 14 grand, depending on the license. So this can be very difficult to buy and get experience with. So if you can get experience with ZMAX or Code V through a university or anyone, try to do so. If you're interested in optics, this is a huge deal. It hurt me in negotiation before because I did not have the experience. They tried to give me a far lower wage, so it kind of caused issues in negotiation. But I was able to show that I knew optical design and I knew it from MATLAB. MATLAB is a wonderful tool. As long as you know the math, you can perform any optics calculations that you want. It is just time consuming. ZMAX is a nice tool. It's like SolidWorks for optics. You can create lenses, customize shapes, you can arrange them however you want. It is quick to do point spread functions, modulation transfer functions. You can perform all kinds of analysis. Tolerancing is really quick. So my advice to you guys is to get experience with optics software. Fred is another one that's a little bit less common, but it's still something that you could use. You need to be able to know how to negotiate your wages. And this is a kind of a two-way street. If the company is small, they're unlikely to have a revenue that's really high. But if you have a larger company that has a high revenue, use that to your advantage. Know that they can pay more, but you also have to know what you're worth. As an entry-level person, you can't expect to be paid that much. But after a couple years, you should really see an increase in the salary that you get. Say you might get 80,000 as an entry level, but in California, you should, after a couple years, you really need to be trying to push to get a wage of over 100,000. If you're not getting area, you're not being paid properly. But you also have to know that the work, the pay is not just based on the company or your skills, it's also based on the work. if you get hired for optical testing or optical alignment, it will not be as in demand or as so stressful or as important as say optical design or optical validation. That is usually a higher wage, and that's for good reason. Multiple jobs. Right now I have 2 jobs. So if you ever do this, you have to maintain a schedule, and you have to keep in mind the time that you spend going to work and back. So right now I have a full-time job, and it takes me an hour to drive there. My second job is closer, but that still means that any weekday that I work, I have at least 10 hours of between driving and the one job, 8 hours of work, 2 hours of driving, and then another 5 hours. So if you work 2 jobs, be ready to have 17-hour days. That's kind of my reality at this time. I do that several days a week. Contracts can be great. It allows you to see so many different subjects so quickly that you cannot otherwise get if you're staying at one company. Problem is that you are the first to be cut if there's a economic downturn, if there is a company downturn. Facebook, for instance, their stock dropped, and then months later they started axing a lot of people. You can get gaps between contracts. Let's say that you have a contract, but then you find another one towards the end. You may not start right away. They may say that you start at a particular time when they're starting a project. So you could be out of work for 3 months, but you have a job lined up, but you still have 3 months of gap. That can happen. Good news is right now there is a lot of work and a lot of demand, but during other times, like before COVID-19, this is a major thing to consider. Working a full-time job for a lot of years can make you very narrow-minded, and it doesn't let you keep up to date on what's going on. Changing jobs requires investigating companies. It requires investigating yourself and what you think you're capable of, and it requires you to push yourself. So most people in the Bay Area, where I'm at, change jobs every couple of years, sometimes a bit longer, but no one stays for much longer than 4 or 5 years. You can also make your own business. This has a lot of benefits and a lot of drawbacks. A lot of businesses fail. That's reality, especially out here due to the costs of having a business. It allows you to do exactly what you want to do with exactly who you want to work with. So if you're working and this is something that you want to do in the future, keep in contact with people that you think you can build a team with. And that's not just in optics. You want to keep in mind that optical systems involve mechanics and they involve electronics. So in your career, if you really do want to start a business, keep in mind people that might also be interested and work in all the subjects that you might need. You might want to have people that are very, very good with analog circuits. You might want people that are good with FPGA. You might want to have people that know optics, but a different field of optics. Say that you want to make a camera and you know lens design, but they know how to make a flash. They know illumination, and they know detector physics really well. That is kind of the mindset to have if you really want to start your own company. I don't plan on doing that in any time soon, but that's something that I'm keeping in mind. And this ties into doing personal, business contracts. If you're good at that and you have a capital and a history, you can start to make your own products. So the one guy I mentioned that does a lot of work with a lot of companies. He has made his own products and he has sold those products. So a business license allows you a lot of ability to do whatever type of work you want, and it allows you to be able to get capital. That is, you can get loans for businesses, and that can help you get a lab set up. Optics equipment is not cheap. I'll say that. All right. One more thing. Maintain your personal life. If you're doing a lot of work, don't forget it. I like to grind stones. All right. Thank you. I'll try to speed this up a bit so we could get some questions. Hello?
Hello. Hi. So thanks for this wonderful talk, Ryan. So I think the floor is open for questions. Please please unmute yourself and you can ask your question directly to Ryan.
Hey, I have a question. When you, for example, transition from the startups, the unfunded startups that you are working with, and then you went to work with Meta, how exactly did that transition happen? Like, did you apply for jobs in Meta for a couple of months, maybe, and then, or did they contact you, and then how exactly did that shift happen? Can you
So
please?
I wasn't looking for, I wasn't looking for work at all at that time. I was working at RKD still. And I'm still there today. I got contacted on LinkedIn. And they asked me for my information. They kind of gave me they kind of had a discussion just to see if it was a fit. And then they submitted my resume. This actually happened repeated times with Meta. Every couple weeks, a company, sometimes it was a different one, asked for my resume. But one of them eventually just got me an interview. The interview process was really bizarre. My interview with RKD was about an hour, and then my second one was a long time of kind of going over my ability. My second interview with RKD was 4 hours. With Meta, I had a 30-minute interview with the hiring manager who would be my boss at Meta. They asked me really simple questions. What is the visible spectrum of light? How would you make white light? And then they asked me what I've done. That was probably the easiest interview that I've had. I do not know if your experience will be the same, but there wasn't even a second interview. I got called back the next day and I had a job. And then we just found the date to start. I made a deal with RKD that I would still perform work with them. I would still perform work in finishing designs. I did not want to leave them without finishing projects. So I'm still working with them and I was able to maintain that. But the interview process for Meta was extremely easy. It was bizarre. And the application was really just being contacted on LinkedIn. The same thing happened for Quanergy. Hello?
Hello. Yeah. So I think we have one more question from Hasib. Okay, and Hasib is saying, hello Ryan, great presentation. I am currently learning a bit of Python programming. If you have experience with it, can you share which libraries / modules are beginner friendly for photonics?
All right, so I used let's see, basically I used a lot of math ones, but I also used like TK, Tkinter. That one I used quite a bit. At Meta, I was using Python for basically picking out parts of an image. Say that you got an image that was from what a display made. So anything, any modules that you can use to pick apart like dead pixels or bright pixels. I use.
Yeah, go ahead. Hello, Ryan. Please go ahead. Yeah.
Okay, yeah, so as far as other modules, at RKD, I was making a GUI, so I used tkinter a lot there.
Okay.
But yeah, I more or less use Python for mathematics. That was my primary use for it. Mathematics, but also control of microcontrollers. So
Okay.
yeah, so that, yeah.
Okay, so we got another question from Sakib. Okay, so he's saying, "Hello Ryan, I want to know what is difference between optics and photonics? What is the difference between optics
Okay,
and
so
photonics?" That is basically his question. Yeah.
there's not really that much of a distinction. Photonics might be more akin to like devices like detectors like CMOS or CCD, but it's all the same subject. Optics might generally, if in job ads, might involve more with lenses, lasers, while photonics might involve more maybe more semiconductor devices or telecommunication. But you'll see it from either. So in any search terms, you can choose photonics or optics, and you can probably get similar results in terms of work. But I don't think that there's much difference.
Okay. So I have a question, Ryan. Most of the audiences are here today. They are doing their undergraduate. Okay, and so you talk about the optical software, and you mentioned about the CMAX optical optics studio. Okay, so let's say like if they can manage somehow the GMAX optical studio, and what thing they can do, and I mean like what they can start with, like what kind of design they can do initially.
Design microscopes. ZMAX does not include any mechanical, but try to make lenses that can help you look at small things or faraway things. Try to look at it for different ranges of spectrum. Maybe make one of the first things I did was I made 2 cylinder lenses up against a edge emitter diode to make it circular. So I would just say, if you're a student, try to make a compound microscope, and then maybe try to make a confocal. Try to add in detail. Maybe your first compound microscope design had distortion or didn't have a very good depth of field. Maybe you had some chromatic aberration. You can start adding lenses and trying to take care of these aberrations. So I would say start with designs that are public, even ones for off of Wikipedia of like basic compound microscopes, and then try to create that in ZMAX and then add to it. Make it better. Maybe you want a compound microscope that's only in one wavelength. Maybe you want to use like a red LED for your illumination that has a very narrow wavelength. Maybe you want to do that. So I would suggest starting with something simple that is built and that you can actually calculate by hand, and then going from there.
Okay, thank you. So I have another question.
Another thing is laser beam. If you look up parts on like Edmunds or Thor, try to recreate it in ZMAX.
Okay, thank you. So I have another question. I see question in our chat box. Okay, before I go to that, I have another question. So you said like you did a bunch of calculation using MATLAB, right? Initially,
Yes.
before you learned all kind of optical software. What kind of calculation you did with MATLAB?
So with MATLAB, I started with I had no idea how to use it at first for optics. I just knew the mathematical equations for refraction, diffraction, and I set up arrays. Say that I had a point source, I set up rays that would emit from different directions over a fan angle, and I had it going to a line. And I basically defined that for these lines, if it met the curve of this lens, at that line, I would see what the angle to the normal was from the surface, and then I would see how the light would bend. And I checked it by hand, and I did this for every single optical surface. And eventually I developed my own tools, my own basically individual packets of tools. I designed basically just little snippets of code that would let me do one thing. And I built this a library of such things. There are books on optical design on MATLAB that I found out well after I had already began that. So there are books on how to do optical design with MATLAB. So I can't think of the ones off the top of my head that I would suggest, but there are books for that. You'll definitely want to have like the PDE solver. You might want Simulink to do electronics. So yeah, you can do essentially everything that Emacs does in MATLAB. It just might take you more time. Zemax at its root is code and it's just math. So you could do this all in Python if you really wanted to.
I see.
It's just that a lot of companies work with Zemax and a lot of manufacturers give you Zemax files or deal with Zemax files. So you might have to learn that eventually.
I see. Okay, thank you. So we have
I
another
have another
question.
Sure.
Go ahead, please.
So can I, should I ask now or should?
Sure, go ahead.
I have another question, Ryan. You had done your bachelor's in physics and master's in electronic engineering. At a point, you had to make a decision between, for example, going for electronics or power or computer or communication or optics. How did you make this decision that I'm going to go for optics and not? How did you discern between these topics? Was it just because you liked it better, or was there any other factors that you took into consideration?
No, I do like it, but this is intentional. I didn't know what to do after I finished my BS degree. So I wanted to learn applications. So I went from mathematics and physics to electrical engineering, and I still never really learned circuits until I started work at RKD. I did the nanotech concentration. I took a class on radar, took a class on optical fiber communication, and I took a class on adaptive optics. And I always had an interest in imaging and being able to look at small things. And so I decided that I was going to explore that a little bit more. And upon finding adaptive optics, I thought it was just immensely amazing that you could use a mirror to deformable mirror to be able to see that much more. I became kind of enamored by that, by being able to go past the diffraction limit more and more. I also recognize that this is actually probably the largest field in the future. The 5 nanometer transistor would not exist without extreme UV lasers and the optics that etches these designs. So if you think of the semiconductor industry as being one of the pinnacles of electronics work, optics is right alongside of it. So just knowing that, learned what I learned in optical, in the nanotechnology courses that I took, I realized that this is where the future of research really lies, is in being able to manipulate really small things, and you can't really manipulate anything if you can't see it. So optics is kind of a central tool in that end. So in my opinion, other than it just being a very interesting field, I felt that there was going to be a lot of work in the future, and that there's going to be a lot of really, really good work to do. So I think that's also a field where you can end up getting a Swedish prize if that's something that you really want to do in the future. You might have to wait for a while. Arthur Ashkin, who did the optical tweezers, got it at age 97. Nakamura got it at a much younger age, but this is a booming field. So I did like to answer your question. I liked it, but I also recognize that there's a lot more to the field than just, say, a laboratory microscope or a camera.
Thank you so much, Ryan. Thank you so much.
Okay, we have two questions in the chat, and I'm gonna read those. First, from Mirja. So Mirja is an undergraduate student here at EEEDU. So his question, like I'm actually reading his question. Hello, Ryan. Thank you for giving us your valuable time. That's me too. I want to give my thanks to you. Okay. Is there, so Mirja's question is the following: is there any open source optical software for a beginner for optical design and simulation?
Optical design and simulation. If you don't want to do this through MATLAB or through Python, I believe there are. I tried one. It was very difficult. I remember it was not quite right. I may not have downloaded it from the right place, to be honest. But yeah, I believe that there's I think there's a couple of them out there. You'll have to try them out. And what I would suggest, if you just search free optical design software, and try adding like Zemax or Light Tools, and you'll eventually find some of these free tools. What you would do to verify it is try to do a really simple thing, like say refraction through a 3-lens telescope. Choose an object at infinity, have your 3 lenses, and try to see if it makes sense. So if you use one of these free software tools, try to do some work by hand and confirm it. And this is actually something that I want to bring up. A Zemax is not something that will replace your ability to do design. It can make lenses that aren't real. You might have forgotten things that you might really have needed. So there's no real replacement for being able to know how optics works. But I would say for optics software, just try to verify. But I can't remember if I remember it later, I can email Son or Manuel and let him know. I might have it saved somewhere. But yeah, I would just verify any work that comes out of it.
Okay.
There was another question, right?
Yeah, so there's another question. So I think Sakib has a question. I think his question is if you know any industry preparation photonics course. I think that is his question.
Course. Oh, like a preparatory course for entering.
Yeah.
Let's see. I don't know any off the top of my head, but what I would do is get some get like a radiations magazine, or get sign up for like Photonics West newsletters. Try to look at what is new right now, and then buy some books on that subject. Now, I know that books can be expensive. I bought a couple books on quantum optics, and they were not cheap, but there are some books you can probably get that are fairly inexpensive. A lot of used books. One thing I really like to do is I like to look at what's a huge topic right now, and then I'll buy an old book, like I like buying books from the 80s or the 70s. But as far as a preparation course, I don't know of any. There may be, that doesn't mean there aren't. I could possibly look around for one and give an opinion. I could possibly send that to Hassan. But I would say if you're trying to figure out how to enter, look at the current news in photonics, and then maybe dive into the subject and see if you could easily enter that, or if it would take, more study. I don't know of any preparatory courses for optics other than just learning the subject.
Yeah, so we are getting more question. Like, you want to answer? I can read them.
Sure. You
Okay,
don't have
thank
to
you.
leave yet.
Okay, yeah, thank you. So Shomik, he has a question. So he's saying, hello, Ryan. You have explained the aspects of being in the optics industry, but can you provide some advice to someone who is more into research? I mean, academic research on optics. Or is it mandatory to join the industry to do research, considering the monetary advantage? Okay. You mentioned Nakamura, who made
Right.
it
So
through industry. Thanks in advance.
yeah. So this is something that I was curious about. I wanted to do a doctorate. I probably would have. I knew who I would work with. Unfortunately, they passed away. But I wanted to get industry experience first for two reasons. One, um, it's the monetary thing. You don't make as much money in academia, especially not right away, right? The other aspect is I didn't know if I started PhD, I did not know if I would continue on the same subject. I didn't know if I would change my thesis plan 2 years later down the road. Working for a while could help you really understand what you're interested in. The caveat is that you need to get a job that's similar to what your academic interests are. I was fortunate in that sense, and that I was interested in imaging, and I worked at a small company to start with. But I would say if you're academically inclined, this is why I would say if you need money, work in a field that's very close to it, and you might actually be interested in eventually maybe possibly making your own company with some people, getting capital and being able to start your own research lab. This is actually something that I want to do in the future, is have my own personal lab, maybe work with several other people and try to work on products. I wanted to work on a brand new type of laser diode system. For you, if you're really more of the research oriented, there's nothing wrong with working for 4 years and then going back and getting back into academia. That transition can be difficult, but I've known several people have done it. There's a lot of people that go and do their PhD and then go on to work and then go back. There's people who start their masters, or they finish their masters, and then they go work for years and they come back and do a PhD. But this is also why I tell you that you cannot stop reading. It'll make it very hard if you go back to school and you haven't kept up to date on electromagnetism. If you can't, let's say, if you work for years and you cannot prove, or rather derive, Maxwell's equations, you're going to have a hard transition back into academia. And you'll notice that a lot of people, as they go through work, that they gradually forget some basic things. So I'm pretty certain that if I were to ask, I did this at Meta, but I know that if I were to ask people at, let's say, Quanergy, if I were to ask like really, if they're asked electrical engineers, that they may not be able to derive it because you forget, because you get so caught up in the specific task that you're doing that you forget your general knowledge. You will never have better general knowledge than when you've just finished your qualifier exam for your PhD. I think Hassan can probably attest to that. That's your peak of your general knowledge. Yeah. So just be wary that if you do decide to go back to academia after working for a time, make sure that you are not starting from scratch and forget how to do Sines law or how to do how to derive Maxwell's equations. Don't forget electrostatics. It's kind of my opinion on that.
Okay. Any other question from audience? I think we are done with the question. If that is the case, then at this point, I'm gonna ask the president of Photonics Society Bangladesh chapter, Dr. Mainul Hossain, to wrap this webinar today.
Okay, thank you, Dr. Habib, and thank you, Ryan. It was a pleasure listening to you. And I guess the students over here, they kind of learned a lot from your experience. And they're really undergraduates, and they are pretty much interested in the optics and photonics field. And I guess the experience that and the learnings that you shared, it's gonna help them to make the decisions in their career. So thank you once again for the wonderful talk. And with that, I would like to thank all the participants and also the Secretary of IEEE Photonics Society, Bangladesh section, Tabil Ahmed, for doing all the groundwork for this webinar and making all the arrangements. So thank you, everybody, and we hope to connect again in sometime soon. Okay. Thank you.
Thank you, Ryan.
Yeah, thank you guys for having me. If any questions, you can probably ask Asana. I'll try to look up those two details to for the optical kind of preparatory, and I'll also look up the tools that the free tool I had used. I'll send that to Hassan.
Sure.
Yes.
Please send. If you have question, please send me your question. You can email me, and I will forward it to Ryan.
Yeah, I will keep. I'll be sure to answer those questions.
Sure. Thank you.
I hope this was useful for you guys.
Oh, sure. It's really.
Thank you for inviting
I think it's
me
really
again.
helpful. People learn a lot. Yeah.
Okay. So yeah, thank you again, everybody.
Bye.
Okay, bye.